We said that columns that go from the top to the bottom are called groups. And then groups, so we have top to bottom, and then rows will go from left to right. Okay, guys? This is my very squiggly line. All right, and you only need to know the first 20 elements of the periodic table. So that's hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, and you only need to know iron on this part. Okay, so I only need to know 20 from 118, which I think is quite reasonable. All right, so let's look at the second slide here. Okay, so guys, in the previous lesson, we spoke about molecules, we spoke about compounds and elements, right? We said that molecules were the smallest part of a compound. So a compound is a substance made of trillions of molecules that form a compound, right? An example of a compound is water. Water is made from hydrogen and oxygen, right? And when you bond hydrogen and oxygen, you get water. A compound is also a pure substance. When something is a pure substance, it's made from, it's chemically bonded, which means that it cannot be broken down through physical means like boiling, sorting with your fingers, or filtering, right? There's extremely strong bonds between the atoms, so you can't just break them down through normal means. And lastly, all compounds are formed through chemical reactions, right? So if you want to take hydrogen and oxygen and bond them together to form water, you can't just do it like, you would mix your tea. You would take a tea bag and pour some water and then voila, there's your reaction, right? It requires a much more complicated process. But imagine like scientists could come to that point where they could actually create water from bonding hydrogen and oxygen. That would be so amazing. I think that would solve our water crisis in the world, right? Okay, so sorry guys, my phone is ringing. We come to the chemical formulas of compounds, right? So if we look at water over here, we know that water is made from hydrogen, right? And oxygen atoms. Okay, and we have NaCl over here. Who can tell me what NaCl is? Anyone has an idea? Okay, so NaCl is basically sea salt. All right, Na stands for sodium and Cl stands for chlorine. So in your salt, chlorine gives the salt the salty taste, right? And sodium is the fact that the salt can be hard. Okay, and then lastly, we have CO2. CO2 is the stuff we breathe out. It's made from carbon and oxygen atoms, all right? So guys, if I break the compound of water down, if I have a glass of water, that's my compound, right? But if I take a microscope and I want to look at the smallest part of that compound, I'm going to see this little Mickey Mouse shape. So this is called a molecule. One molecule of water, right? This is called one molecule of salt. This is one molecule of carbon dioxide. All right, so today we're going to learn about chemical formulas. You guys learned about symbols in the previous lesson. So in the periodic table, we don't write sodium as the full word. We abbreviate it to be Na. We don't write chlorine in its full word. We write it as Cl for short, right? If we look at water, the chemical formula for water is H2O. It's H2O because there are two hydrogens. So the number next to the element, all right, next to the symbol, tells me how many atoms of that element there is, right, in a molecule. So here it says that there are 2 hydrogens, and can you see that there are 2 hydrogen atoms in this molecule? And how many oxygen atoms are there? Tell me in the chat, how many oxygen atoms do you see? Good, Marcus. There's only 1 oxygen atom, right? And you can see that from the chemical formula. Let's move on to NaCl. So NaCl has 1 sodium atom and 1 chlorine atom. All right, and you can also see it from the formula. There's no numbers here. It's just 1 of each atom. So if I break down salt into its smallest particles, and I look through it with a microscope, I'm only going to see 1 sodium atom and 1 chlorine atom bonded together. And lastly, we have carbon dioxide. Now, carbon dioxide is interesting because we have 1 carbon atom, but how many oxygen atoms do we have? Tell me in the chat. Okay, excellent, Marcus. I'm not too sure why no one else is responding. Let's hope it's not because you guys are confused. All right. So guys, we're going to move on to the next file. Sorry about the noise in the background. Just give me a second. Sorry about that, guys. Okay, the next slide we are talking about is breaking down compounds. Properties of a compound are separate to that of the elements they are made up of. Now let me explain that. So if we look at how water is made, right? We take hydrogen, and hydrogen is a gas, okay? And who can tell me why is hydrogen written as 2 atoms together? What do we call it when 2 atoms are bonded together? It starts with an M. What is it called? When 2 or more atoms are bonded together, we call it okay, so since no one is answering me, we call it a molecule, all right? So we have a molecule of hydrogen, and we take oxygen. Oxygen is also a gas in its natural form, right? So we take 2 gases and we bond them together, and it's amazing because in the end, we have a liquid that forms from gases. So water has totally different properties and characteristics than oxygen and hydrogen, right? So and this over here that you see, a plus sign and the arrow, this is called a chemical reaction. All right, so what does that mean? It means that these guys over here will combine or bond together to give you this guy over here, right? I'm continuing to read. All compounds are formed through chemical reactions. The atoms of elements in a compound are held together by forces known as chemical bonds. So the bond that holds hydrogen and oxygen together is called a chemical bond. And if you remember from earlier, it's impossible to break apart a chemical bond through physical means. So you can't just boil water in order to separate hydrogen from oxygen. It needs to go through a more complicated process. Compounds can be broken down into the elements they are made up of. Break a compound by breaking its chemical bonds. The reaction where a compound is broken down into its elements is called a decomposition reaction. So let me explain this to you in simple terms, right? Just say we wanted to take water and we wanted to separate water into hydrogen and oxygen. Yes, Marcus, you have a question?
Ma'am, how does 2 compounds that are both a gas with a similar density Why is it that when they're bonded together, they create a liquid that is of greater density?
Okay, so I am not too sure about the process, right? But I know that there's sort of a loop, like they go into each other like lock and key. So I will look up that question for you, right? I just not too sure how to put it in words right now, but I definitely will look that up for you. All right. I know if to form salt, we have sodium, which is Na, right, and chlorine, which is a liquid. But when chlorine reacts with salt, then it's when they bond together, they form a solid. So that's one thing I know. But I will get back to you on that. And let me know. Do some research on that and let me know about it. Okay, Marcus.
Okay, ma'am.
Okay, great. So if we take water and we want to break up water into hydrogen and oxygen, which by the way, you can do, right? I'll show you guys a video later. So can you see how I turned that arrow around, right? So now, because I want to break down water, and this kind of reaction is called a decomposition reaction. If I break it down, I'm going to break it down into its simplest forms, which is oxygen and hydrogen, right? Okay, we're nearly done, guys. I just want to show you something called a ratio. So if you've done maths, you know that a ratio is when you have one thing on one side of a colon, this colon thing in the middle, and you have another number on the other side of the colon, right? So let's look at salt, which is NaCl. By the way, Na is sodium, Cl is chlorine, okay? So because we have one sodium and one chlorine, this is how it's going to look like in ratio. But if I had a number that came before NaCl, oops, this went all the way there, then this means that I have two molecules of salt. So this is how it's going to look. This is how it's going to look in the end. If I decide to put a 2 before the compound name, right, I'm going to have two molecules of NaCl. All right. Is this making sense so far? I hope this is making sense, guys. All right, let's look at water. If I had to put a 2 in front of water, right? How many molecules of water do I have now? Tell me in the comments. If I put a 2 in front of water, how many molecules of water do I have now? Yes, Marcus, I have 2 molecules of water, right? That means that I am going to be left with this guy and this guy bonded together, right? That's how it's going to look. How many hydrogen atoms do I have now that I put a 2 in front of this molecule? If I count, I have 1, 2, 3, 4 hydrogen atoms. And there's a little bit of multiplication and addition here, right, guys? But it doesn't get more complicated than that. So if you are scared that I'm gonna be teaching you maths, I'm not gonna be doing that. This is just like simple multiplication and addition. Good, Quentin. Excellent. So there's 4 hydrogen atoms, right? So whenever I put a number in front of a molecule, I need to times it by any number that's inside. So 2 times 2 will give me 4 hydrogen atoms. And how many oxygen atoms are there, guys? You can count it on the diagram. Okay, there are 2 oxygen atoms. So if we count on the diagram, it will be 1 and 2. Good, Quentin. And if we want to count it from the formula, we know that the number in front of the molecule, we need to times it by this number here. So because there's no number next to oxygen, we're just going to imagine that it's a 2. It's a 1. right? So that's an imaginary one. We don't put it there, right? We just know that it's 1. So 2 times 1 is 2. So in total, this is how the ratio is going to look. All right, guys, if it seems a bit difficult at first, please don't fret. I promise you it's not difficult. Let's look at CO2. If I put a 2 before this molecule, how many, first of all, what is C? What does C stand for? What does C stand for on the periodic table? What element? Carbon. Good, Marcus. So how many atoms of carbon do I have now that I put a 2 in front of carbon? Do I have 2 or do I have 4? 2. Good, Quentin. Well done. And how many oxygen atoms do I have? Remember, I have a number next to oxygen. And I have a number before this molecule. You can guess. Quentin says 2. It's actually 4, right? I think this is Stendo who's answering me now. So why is it 4? Because remember, we take the number before the molecule, this number here, and we times it by all the numbers inside, right? So 2 times 2, good Sarah, is 4. So this is how it's going to look. Let's do a few more of these, right? And let's see if you guys can get it. For those of you who are finding it a bit difficult, I promise you, you're going to get it. Let's just practice a bit. Okay, how many sodium atoms do I have now? Sodium is Na. And remember, there's an imaginary one next to sodium. There's an imaginary one next to chlorine. Sando is not in. Then who's Dubai? Okay, so
I am.
Oh, hi Muawiyah. It's awesome that you answered. Thank you. So there are 3 sodium atoms, guys, and there are also 3 chlorine atoms. And let me show you why. Because remember, I said that there's an imaginary one next to each element. So we have an imaginary one there and an imaginary one there, right? 3 times 1, let me even draw this for you guys, right? 3 times 1 is what? 3. And 3 times 1 is 3. Do you understand why now you have 3 of sodium and 3 atoms of chlorine? Does it make sense? Okay, I'm going to do another one. Let's put a 3 before CO2, right? Remember, guys, this number here, this number here, it represents how many molecules of carbon dioxide there are. So there are now 3 molecules of carbon dioxide. And how does that look? That looks like this. I'm just going to copy and paste for you guys and show you. Oops. Okay, so altogether, this is how it looks. All right, if I have to put a 3 before I put the molecule name, that is how many molecules I'm going to have. Just say I decide to put a 2 here, right? Then I'm only going to have 2 molecules, which is basically that. If I take away the 2 and I put a 1, I'm only going to have 1 molecule. What is a molecule? When you have 2 or more atoms that bond together chemically. All right? Is everyone on the same page? If you're on the same page with me and you're understanding, I want you to write yes in the comments, just so I know where you are. Okay, Chloe, it's nice to hear from you. Yes, excellent. Okay, Ethan and Jensen, you guys are quiet. Okay, Aria is understanding. Quentin's on my page. Good. All right, so if we put a, and I think that's Tendo. I think KFC is Tendo. If I put a 3 before carbon, all right, how many carbon atoms do I have now? Remember that I have an imaginary one always next to the, I don't know why it's not coming out, but anyway. So now I have 3 carbon atoms, and I want you guys to tell me how many oxygen atoms do I have. So I take 3 and I times it by 2, and I have 6. Excellent, Maria. Well done. So this is the amount of atoms I'll have in the end. All right, guys, I think you're getting the hang of this. And if it's looking a bit difficult, it's okay. We're gonna practice a lot of this. All right. That's basically the end of this lesson. I just want to let you guys know that in a chemical formula, these things that you are seeing in front of you are all chemical formulas. NaCl, CO2, H2O, those are called chemical formulas. And you will always find, for example, in a water molecule, there'll always be 2 hydrogens and 1 oxygen. If there's like 3 hydrogens and 2 oxygens, then it's not water, okay? All right, that's the end of the lesson, guys. I will send you homework on Google Classroom.